Now we'll be solving question number 12 from previous year problems from chapter Forces and the Laws of Motion, phase 1. Okay. Now let's see the question. A system shown in the figure is like equilibrium and at rest. This is a system which is at rest and it is in equilibrium. The spring and the string are massless. So this is the spring and this is the string. Both are massless. Now the string is cut. So I'm going to cut this. The acceleration of mass 2m. So this is a 2m mass. So we have to calculate the acceleration of 2m mass as well as the acceleration of m mass when we are going to cut this after the string is cut. So this is the question which came in 2006. Okay. Now, so let's first see how much elongation is there in this spring. To check the elongation in the spring, what I'll do, I'll assume the 2m and m both are part of my system. If both are my system, then the mass of the system will become Pm. So let me make the FBD of the combined system. If I make the FBD of combined system, the Cmg is acting downward. Because now the system is 2m and m. Now there will be spring force acting in upward direction. Let's say that is Kx, where x is the elongation. Let me call it x naught. The system, according to the question, is in equilibrium, so acceleration is 0. If I balance it, I'll get Kx naught minus 3mg is equals to 0, and that is giving me the x naught value as 3mg by k. That much elongation is there in the beginning. This is spring. Now I'm cutting this string. The moment I'm going to cut this string, now I have two particles. Particle M, which is not all connected to anything, and the particle 2M, which is still connected to the spring having this elongation. So let me solve it side by side. So this is for M and this is for 2M. So when I talk about the mass M, if I make the FBD of mass M, now after cutting the string, only one force acting upon it. The moment I'm cutting the string, the tension is gone. So only one force is acting upon the mass M, and that is mg, which is downward. Only one force, so in the direction of force will have an acceleration A. So net force is mg, and that is equals to m into A. So acceleration comes out to be g. So the mass M will go downward with acceleration A after cutting the string. Now let me check for the 2m mass. If I'm making the FBD for 2m mass, now the thing is, for cutting the string, this 2m was experiencing three forces. It was experiencing 2mg downward direction. It was experiencing the tension from this string in the downward direction, and it was experiencing the spring force in the upward direction. So there were three forces. But the moment I'm cutting the string, tension is gone. So only two forces remaining. One is 2mg in the downward direction, and one is kx naught. So see, the moment I'm cutting, all these calculations I'm doing after cutting the string, exactly after cutting the string. So the string will have the same expansion which it was having earlier, this one. Now, I'm assuming the acceleration of this to mass A in upward direction. So whatever direction of acceleration I'm assuming, same direction, force will be positive, meaning this force will be positive and this I'll take negative. So that gives me Kx naught minus 2mg equals to 2m into A. Now please focus here. Generally we take F is equals to ma, but in this case, mass of the system is 2m. That's why I'm taking F is equals to 2m into A. Now, the value of Kx naught from here, no, it is 3mg minus 2mg, that is equals to 2ma. And that will give me the acceleration as g by 2. I'm getting the positive value of acceleration. It means the direction I have taken for acceleration is slight direction, meaning it's upward. So final answer, I'm getting that 2m mass is going upward with acceleration g by 2. And the m mass will go downward with acceleration g. Now let's check the options. If I check the options, option A is saying G by 2 upward and the G downward. Yes, that's the answer I'm getting. Okay, so in this question, the right answer is A. This is a nice question with a little bit calculation. Okay, so we had to make CFPDs to finally get to the answer. Okay, thank you.